said that the tangent of theta is equal to, is that 3 over 5? No.
Yes.
3 over 2.
3 over 2, sorry.
So I'm going to draw a triangle. That's my angle theta. This represents the opposite side. That represents the adjacent side. So that means that the 3 goes there and the 2 goes there. And then I have to find the hypotenuse.
Mm-hmm.
So 3 squared is
9
plus
4, so it would be 13.
So this is the square root of 13. And then if I want to say what the sine of theta is, that's equal to opposite over hypotenuse. Mm-hmm. And so I put in the numbers.
So it would be 3 over square root of 13, which would equal 3 times square root of 13 over 13.
Right. So you have to do each one of the sides of the triangle so you can figure out what sine and cosine are. Like sine is not just 3. Okay? Mm-hmm. So just when you're doing those, just draw the triangle, label the sides, and then just use the trig functions.
Okay. And then after 12, 15. It's like simplifying trigonomic expressions, like 1 over cotangent squared x plus 1. Tangent squared with, is it cosecant squared over 1? Cosine squared.
Yep. So you have to do those.
Yeah, that's just the beginning. So that was all of 501 that we really touched on.
Okay.
5-2 starts at 25.
Bless you.
Thank you. And that's
proof stuff.
Yeah, verify the identity. So it's cosine x parentheses tan squared x plus 1 and in parentheses equals secant x. So let's see, tan x plus 1.
What identity has tan and 1 in it?
That's secant, right?
Mm-hmm. Secant squared.
Secant squared, yes. And secant is also equal 1 over cosine, so it's 1 over cosine squared, so then one of the cosines would be cancelled. So it would leave just secant.
Good. Okay.
25, 26 is the same. 33. 33, there's a negative x. So it's cosecant negative x and over secant negative x. Equals negative cotangent. And isn't
which one?
Cosecant, I can't say the name right now. Top one, it's not negative, while the bottom one is negative. So I'm pretty sure cosine is negative. I think I brought the sheet.
Cosine. So the bottom one would be negative because sine is even, cosine is odd. Right. Right. So this one would just be cosecant x, and that would be negative secant x.
And that's just equal to cotangent.
Well, okay, yeah. So that's negative cotangent x. Negative cotangent x equals. Yeah.
And for number 36, it has a pi in it. That's cosecant x sine parentheses pi over 2 minus x.
X sine of pi 2 minus x. And then that's equal to
1.
Well, this has a phase shift in it, right? So if you take negative sine x and you shift it to the left, pi over 2, what function do you get?
Cosine.
Mm-hmm. And that's equal to 1.
Well, where does the negative x go? How does that turn positive?
Okay, let me draw it for you. So this is negative sine. Right? And then I'm going to take negative sine and I'm going to move it to the left, pi over 2, because that's the phase shift. So this is what the next picture is going to look like. And of course it goes like this on this side. So I'm going to take all of this, and this is pi over 2, and I'm going to move it that direction.
Mm-hmm.
So my new picture looks like this. Right?
Mm-hmm.
What's that the picture of?
Just the sine.
Just the sine. I'm sorry. I'm moving it pi over 2, so I wouldn't move it. I moved it a full pi. I need to move it pi over 2. So let me go back. So pi over 2 is here. So then I'm going to shift it that way. So it's going to look like it's actually negative cosine.
Yeah, that was my main question. Why? Where'd the negative x went?
Well, the negative x, I could rewrite it this way. Let me do it this way. So what if I did the sine of x minus pi over 2, and I put a negative 1 there. That actually makes more sense now. So let me pause this.